Any questions over any of the previous homework assignments so far? So what we're going to finish up this note sheets with is the complex fractions, these here. And when we covered these the first time, we looked for a least common denominator. We looked for something we can multiply the top and bottom of the fraction by to get the fractions in the numerator and denominator, the top and bottom, to simplify out. Now, when we look at this problem here, there's only two fractions in the numerator and denominator. And they're the 1 over x squared and the 1 over x. So we need to determine what would we need to multiply the 1 over x squared and the 1 over x by to get the denominators to cancel. So what times 1 over x squared would get that x squared to cancel? It would be x squared over x squared. And what would we need to multiply the 1 over x by to get its x to cancel? X. Well, do we already have it with the x squared? Well, yeah. So here we don't need to multiply it by another x because we already do have one inside the x squared. Now we can see that when we multiply this through, because we're going to multiply the entire numerator and entire denominator by this here. So we're going to have 1 times x squared, which is x squared minus x squared times the numerator 1 would be x squared. So when we multiply x squared by the entire numerator, we're going to have x squared minus x squared over x squared. We'll do the same thing with the denominator. X squared times the 1 would be x squared. And x squared times the 1 over x is going to be minus x squared over x. Any questions on this here so far? Now we will have some simplification. X squared divided by x squared. This here would simplify to 1. Anything divided by itself is 1. So x squared divided by x squared would be 1. Now in the denominator we still have the x squared minus x squared divided by x. It would become 1x, or just x. Because when we have like bases that are being divided, we subtract the exponents. 2 minus 1 would be 1. And since it's bigger on top, it stays on top. Any questions on how we got to this point here? Now at this point here, we can't just cross out the x squared because on top we have x squared minus 1, on bottom we have x squared minus x. For us to be able to simplify, we need to see if we can factor and go from there. Well, the numerator is factorable. It is a difference of perfect squares because x squared is a perfect square and 1 is a perfect square, which would give us x plus 1 and x. Now, unfortunately, the denominator is not a difference of perfect squares because x squared is a perfect square. It'd be x times x. But x by itself, x to the first power, there's nothing that multiplies together to give us just x besides the square root of x and square root of x. But there is something else we could do. We can factor out an x, yes. Because there is an x in common with x squared and x. And if we pull it out, the x squared becomes x minus 1. Now the x minus 1 and x minus 1 will cancel, leaving us with x plus 1 over x. unfortunately, we can't cancel these out because the x plus 1 on top is stuck together. Now, I'm going to go actually back a step to this here before we canceled out. Now, what we talked about yesterday was multiplication, where I have two things being multiplied together, two rational expressions multiplied together. We multiply the numerators together and the denominators together, yes? And we multiplied the numerators, we realistically got something that looks like this, x plus 1 times x minus 1, yes? And in the denominators, we multiply those, we got something that looks like x times x minus 1, yes? So I could easily break those two back apart before we multiplied. So I could say that I have an x plus 1 and x minus 1, easily going back apart, yes? Well, here, when I split these apart, I could split them different ways, but if I do this here, break those apart, now the 1 I have is x minus 1 over x minus 1, yes? Anything divided by itself is 1. So this here would simplify to 1, which actually just leaves us with the, bless you, x plus 1 over x. So when we go through that process of the previous step where we're just crossing it out, this is really what we're doing, is that I'm taking it from this form into this form, splitting those two, anything that's in common with that multiplication, putting it over the top of itself out to the side being multiplied. Well, all of those, as we see here, just turn into 1, and we're now with this here, we can do a similar type, but with addition subtraction, it's a little bit different. Because when we covered addition and subtraction previously, for us to be able to add or subtract, the denominators have to be the same. So if I wanted to split these up, really I'd have to keep the denominators the same, and since the sign between the numerators is plus, we can have it as that way, which would be x over x, and here would be 1 over x. Well, x over x simplifies to 1. I still have to have that plus 1 over x. But has this really gotten any simpler? Well, no, because x plus 1 over x really isn't any simpler than 1 plus 1 over x. Because of that division of 1, which we do have here, we can do it, but it doesn't have the same effect as when we are multiplying with 1. Because multiplication of 1, this here really just goes away and we're left with this. So that's nice, because it actually is making it simpler. We do have less terms. Here, when we do it with addition and subtraction, trying to break it up and simplifying, I've now made two distinct expressions. It's not made it simpler, it's kind of made it longer. So that's why addition, subtraction, we don't want to kind of do that breakup, but we can with multiplication because it actually does make it simpler, easier to work with. Does that kind of make the difference between those? Because that sometimes gets confused why we can do it with some but not others. Any other questions on this here? Okay. Let's look at this next one here. Now again, the main goal is to get all the fractions out of the numerator and denominator. Well, luckily for this here, we only have one fraction, and it's in the numerator. And the denominator is what? A. So what do I need to multiply by? A over A. Well, A times 25 over A is going to be 25A over A minus A squared. We do it with the denominator. A times 5 is 5A plus A times A is A squared. when we do the multiplication with the denominator, am I actually adding anything else back to it? Because here we have a times 5 plus a, yes? The numerator, I do kind of have a subtraction something going on, yes? But if I'm going to simplify it, I really need to pull that greatest common factor of a back out. So really, did I need to multiply the a through? Not too much. Partly because there's nothing else added or subtracted. I don't have two fractions in the denominator to combine. We needed to do it to the numerator because we needed these a's to go away, yes? But in the denominator, we don't have any simplifications. Now that probably is bringing up the question, like, when do I know to do it, when do I not? Now when I did multiply through by a, did it actually change anything of what I needed to do? Well, no, right? Because we ended up factoring it back out. So if I'd noticed here, hey, I don't actually need to multiply it through, and just left it as a times 5 plus a, well, I kind of got here, yes? Well, if I didn't notice that, I multiplied it through, and say, okay, I need to factor it back out, well, we got to the exact same place, yes? So it's one of those things, if we notice that, hey, we don't need to, we can kind of skip that step. If we don't notice it, well, it doesn't hurt us, because we can go on, factor it back out, and get back to where we need to be. Does that kind of make sense? So on some of them, if we see we don't necessarily need to multiply it, hey, we don't have to. But here, missed it, so, well, I had to pull it back out anyways. Now, all that said, what's left in the numerator? 25 minus a squared. Well, 25 minus a squared, is that a difference of perfect squares? Yes. And how would that factor? Almost. Because what number goes first? So no, what number came first? 25, yes? 5 would go first. 5 plus a and 5 minus a. So saying a plus 5 is actually not incorrect, because 5 plus a and a plus 5 are the same thing. The only issue comes in is a minus 5 and 5 minus a are actually not the same. So that's the only hiccup. But that's it there, and that's what's nice about the perfect squares. They pretty much, we take the square root of them, put them in, plus minus. We just need to make sure the order's correct. And last but not least, we can cancel these two out, leaving us with 5 minus a over a. And that right there is as simplified as it gets. Any questions on this here? All right. Okay. We'll look at least two more, because I know there's 4 more left, I believe. This one, next one, and then 2 after it. Okay. So let's look at this one here. So again, we want to simplify all the fractions out of the numerator and denominator. So what do we need to multiply the top and bottom by? The x plus 4. Because we see the only thing in the denominators, in the numerator and denominator, is the x plus 4. So we need to multiply it by it to get it to simplify. So on the top, we're multiplying the x plus 4 by each of the numerators. So the first one, we're going to have 3 times x plus 4 over x plus 4 minus 2 times x plus 4. We'll do a similar thing in the denominator. So we'll have the x plus 4 times 5, which would be 5 times x plus 4 plus. And again, when we multiply with fractions, we always multiply with the numerator. 2 times x plus 4 over x plus 4. Whole numbers times a fraction will multiply the whole number with the numerator. Fractions times fractions is tops and tops, bottoms and bottoms. Any questions on this here before we start simplifying? So when we simplify here, the x plus 4 and x plus 4 would cancel out. Here the x plus 4 and x plus 4 would cancel out, leaving us with here 3 minus 2 times x plus 4. In the denominator, we're going to have 5 times x plus 4 plus 2. Well, we'll still have to distribute and simplify so that we do have it all the way factored down. Cancel the 2x plus 4s. We still have the addition subtraction in the middle of them. They are stuck together. We can't just cross them out. Because if we were able to, we would be able to actually split them up as x plus 4 over x plus 4 times the other. Since we can't necessarily do that with addition subtraction, because with the addition subtraction, if we tried to do that, we would get 3 over 5 times x plus 4 plus 2 minus 2 times x plus 4 over 5 times x plus 4 plus 2, because the denominators have to be the same. So we can't necessarily do that simplification here. Does that kind of make sense? Because we really need it to be the same on top and bottom, which if they're being multiplied together, we have multiple things in the numerator being multiplied, and in the denominator, we can actually break it apart a lot easier than if there's addition subtraction separating the terms. So to really get to the point where we could simplify, we need to distribute the negative 2. Well, negative 2 times x is our negative 2x. Negative 2 times positive 4 would be negative 8. Now 5 times x is 5x, and 5 times 4 is plus 20 plus 2. In the numerator, we do have the negative 2x, because there's no other x terms. And the only real like terms are 3 and negative 8. And 3 minus 8 is negative 5. In the denominator, well, we'll have the 5x. And 20 plus 2 is plus 22. Now, before we can simplify, we need to be able to write this as multiplication, things multiplied together, so factoring out terms. Is there something we can factor out of the 2x and 5? I mean, we can factor out the negative 1, but that's not going to do a whole lot. Can we factor anything out of the 5x and 22? No. So that there is actually the final answer. Because unfortunately, trying to simplify this with addition and subtraction doesn't make it simpler, it makes it bigger and a little more complex. So unless we have things multiplied together in the numerator and denominator that do line up, then we can simplify. Here, unfortunately, we don't. Any other questions on this here? Mm-hmm. Here and here? Here? So here, really what we're looking at is 2 times x plus 4, and they're both being divided by x plus 4, yes? So really what this is telling me is that I have 2 times the quantity x plus 4 over x plus 4. Well, x plus 4 divided by x plus 4 is 1, so I have 2 times 1, which gives me 2, is what we have for this part here. So that's why we can get down to this 2. But when we get down to this here, we've got 2 things added together. Let's say here I've got 3 minus 2 times 4 over 2 times 4 plus 5. And this is not one of the problems, but I think we'll make this make a little bit more sense if we look at numbers, not variables. Now, essentially what we're asking and kind of what we're looking at is probably getting to these 2 4s here, wanting to cancel those out. Now, if we cancel, let's say we left them alone first and see what we get. Well, in the numerator, because 2 times 4 gives us 8, yes? And the denominator, 2 times 4 gives us 8 plus 5. On the top, we have 3 minus 8, which is negative 5. And 8 plus 5 is 13. So we can see, okay, we're good with saying that when we simplify that, we get negative 5/13. Yes? Now, say we went through and said that these 2 here simplified. Or heck, we could say, which would leave us with what? 3 minus 2 on top, yes? And in the denominator, we would have 2 plus 5, and this should get us back to what? Negative 5 over 13, yes? Well, 3 minus 2 is 1, 2 plus 5 is 7. Are these anywhere near the same? No. And it's really almost, well, I don't want that. Almost there. It's really dealing into the fact of this addition subtraction that's locking those together and how that works. Does that kind of make a little more sense? Because with multiplication of a times b over a times c, the fact that I could rewrite this as a over a times b over c and simplify these out is where the simplification really takes place. Because with this multiplication, with addition and subtraction, we've really got to simplify the numerator and denominator before we can find what's in common. Does that kind of make sense? So, and I think that's kind of where the issue comes in when we start looking at all this here. Because of the addition and subtraction here, we've got to simplify the numerator and denominator as completely as we can before we can start canceling things out. Because we do have this, especially here and here, but because of this subtraction and addition inside the middle of it, it's locking them all together. We can't just cross out. Hopefully that made more sense and not less. All right, we're going to look at one more. So we're not going to do the rest of these because I think for most it's getting more sense, it's making more sense since we've seen a few of these. So this here, we do need to multiply the top and bottom by the same thing. Now we look at this here, we're trying to see what do I need to multiply each of these terms by so we get the denominators to cancel, to simplify out, so that we can get the same thing on top and bottom. So for the x plus 1's in the denominator, I'm going to need to multiply them by end x plus 1, because when we multiply the top and bottom, we're multiplying each one of these by the numerator of each of the terms. Is there anything else that we need? The x. Because here the 1 over x and 1 over x, if we get it multiplied by x, the x over x would cancel. So we multiply this here. We're taking this term, this whole term, and we're multiplying it by the numerator of each one of these fractions. Because we're multiplying a fraction by an entire fraction. It's got fractions in top and bottom. So this is multiplying by the numerators. So we have x times x plus 1 times x. Since the x's are both outside, we would multiply those together. X times x is x squared times x plus 1. And this one here is over x plus 1, because that's our first fraction in the numerator. Our second fraction is the 1 over x. So we know the denominator is x. And we're going to multiply the numerator of 1 by x times x plus 1, which stays x times x plus 1. We'll do the exact same thing to the denominator. So we're going to take this entire terms here and multiply by the x and the 1. Now the denominator for the first denominator fraction will stay the same. It's still going to be x plus 1.
I'm just disrupting class.
So we're going to multiply by the numerator x. Well, again, the x and x will multiply together to give us x squared times our x plus 1 plus the denominator for the second fraction's denominator will stay the same, because it still will just be x. Because when we multiply, we're not multiplying and changing the denominator of the fraction, we're only changing the numerator. And when we multiply by 1, we get back to where we started, x times x plus 1. Now looking at each one of these fractions individually, because we do have multiplication on top and a single term on bottom, since these here are the exact same, they would cancel. The same thing is true for these x plus 1's. And here the individual x would simplify with the individual x. And again, we're doing this because of the fact that we do have multiplication on top and bottom, not the addition subtraction. And when we do this here, what we're left with in the numerator from the first term is just squared minus x plus 1. Now we need to be careful with that x plus 1 because we're subtracting it. The signs will change because of our subtraction. So we can leave it inside the parentheses. Now the denominator will have the x squared plus x plus 1. Now for the denominator, because it is plus, it's not going to really affect the signs, but it's not a bad habit to have of having those parentheses just in case. Now our numerator, that negative will be applied to both the x and 1 because we're subtracting the x and subtracting the 1 from the x squared. We can't actually subtract x squared and x squared and 1, so it ends up looking like x squared minus x minus 1. When we add the x plus 1 to the denominator, we get plus x plus 1. And that's actually it, because x squared plus x plus 1 is not factorable. Because if it would, we would need the middle term to be 2x, or have 2x squared. Actually, just be 2x would be the most likely one for it to factor. For the numerator, we would either need 2x squared or minus 2 for us to be able to factor that one. And one good way to check is the square root of b squared minus 4ac, because if we plug that into the calculator for a, b, and c, and we get a whole number, then it's telling us that it will factor. If it gives us a negative number coming out of this here, or I, for the graphing calculator gives us a term with I, we know it doesn't work. If it gives us a decimal, it doesn't work. It doesn't factor. Are there any other questions on any of these here? Okay. Well, that is it.